Welcome everyone out there in radio and TV listening land to the next episode of the Past, Present, and Future Open Science Emergent session. Today, we are featuring containers, ticket to Valhalla or ticket to the Inferno. We have a lot of guests joining us today, and I want to set up a little bit of stuff before we get started. Being from the Repronym land, I kind of push this concept of containers for everything. And then of course, Yarek out there reminds me, maybe not everything, but for anything you can containerize should be containerized. And that's kind of the mantra Nitric lives with, and Nitric and Repronym lives with. And then you run in, to people like Gael and Pierre who start to say, oh, containers are bad, never use them. And then the poor researcher is stuck in the middle who believes, yeah, I want to use containers. Someone gives me containers, but they're hard to use. So I really wanted to take this opportunity, and this all sort of came up in a Mattermost thread earlier in the week, that we really wanted to look at this topic, not maybe solve this today, but really understand better about what it is that's bad about containers. Certainly there's issues there. What is it that are good about containers? Well, we need to understand that too. And what is it that's making those hard? So that at the end of the day, we can have a nice list of these things, and that gives us all an opportunity to figure out how to fix the things that are problems, how to understand where containers are right and containers are wrong. So the goal of today is very brief lightning sessions from a handful of people we threw up here on the stage, but then hopefully the rest of you as well, to collect a list of all the good things about containers, of all the bad things about the containers, of all the problems you run into, and all the solutions that are out there. But we know that answer depends on who you are and what environment you're working on and what world you live in. The same statement about problems or good things and bad things may or may not apply to all these different user worlds. So we'll try to have people couch their perspectives given their world that they're working on, and we'll work through a couple of those. The format is we'll have a handful of speakers pre-selected, and hopefully then turn it out to the questions and texts from the real world. There's 4 minutes max per person, and I will be authoritarian. We want to identify what world you're coming from, and then to speak on the topics of good, problems, bad, solutions, etc. There is a scoreboard where we're trying to keep all these notes, and then try to, in the end, not solve these things today, because each thing is probably an hour or more session. Each thing already has some materials out there in the world. We don't want to rehash that. We want to come up with this list so that we can create for the community, by the community, a good understanding of what the real best practice and the different application areas for going forward. And so with that, I will kick over to the scoreboard document, if I can, sorry, and turn over the floor to our first speaker, Gael. Gael, are you with us?
Gael, you're muted.
I am muted, of course. So I love to complain, first thing. Second thing, I'm a research director at INRIA and visiting professor at McGill. I'm a tool developer in the sense that I'm a method researcher, and I'm quite active in a certain amount of open source software. The one you're most likely to know is Nylearn. I also consider myself as a researcher, and I'm interested in developing tools to use them. So we're talking about containers. Let's first take a step back and think, what have containers been built for? They've been built for wrapping a production environment and then shipping it to many different production machines. And they're used daily by a huge industry to do this, basically cloud computing, working on the cloud. Now, what's the problem with containers? Well, there's an old joke in software engineering that when you have a problem, you just do an abstraction layer on top of it. And then when you have a new problem, you do another abstraction layer. And the problem with this is as you add abstraction layers, you've never solved the original problem, and you've just increased complexity. And it, breaks down. So what are the actual problems we're trying to solve? There are numerical stability problems, there are statistical issues, there are installation problems. We're not solving them. we're hiding them. We're encouraging bad practice from the tool developers, such as not worrying about portability, dependencies. We're creating a lot of overhead, and it's not about computing overhead. It's about process overhead. We're making modifications harder because too often containers are distributed as a black box, whereas we really want things as simple as possible to inspect and understand. And if we keep going in this direction, the future that I do foresee, and I really see it, is when we're trying to get lots of software working together, each one of them packaged in different containers, and then having compatibility problems between those different containers, and then we're going to have a container of containers. This is really going to happen if we keep trying to containerize everything. So, what are the solutions? Well, above all, better, underlying tools. Jarek says, something not solving a problem is not bad. Sure, I see nothing wrong with containers. I just see them wrong in the way they're used. They're very good to, productivize things at Amazon. They're not great for the problems we're trying to solve. So, we should have better tools and stop pretending that containers are going to solve our problems with our tools. Thank you.
Thank you so much. I was going to say, don't let Jarek steal your 4 minutes, but okay, I think you used that well. So moving on then, I turn the floor over to Pierre.
Yeah, hi folks. As predicted, not easy to follow Gael on any of these kind of things, but I know that before coming in. So my name is Pierre. I'm a postdoc at McGill University working with Jean-Baptiste Bollin and also Gael. And I will also provide some points of view from my experience packaging one out or the other software package or pipeline into containers. So I think that testing software in various different aspects in containers can be nice and helpful. Of course, if it's done right and you know how to do that, and you can also tell other people how to do that, I think they make for very good applications in case the community agreed to a certain amount of standards or standardization of certain aspects. For example, like bits apps make a good use case there. The deployment across different systems and architectures and scales going from personal computers to HPC is possible, which might be a bit of a problem outside containers. And it requires software developers and tool makers to very precisely think about the dependencies and architectures they want to build into their containers and software packages and whatnot. On the contra, I think, as Gael nicely outlined and summarized, there are no real panacea, of course. It's only for some aspects we're trying to tackle, not all of them. If you do not pay close attention, they can get very large very fast, and no one wants to have 10 containers with 10 things, and each of them is like 10 gigabytes. That's not what we're trying to do, right? Unfortunately, there are no standards regarding generation and sharing of containers, and dependency tracking, as also mentioned by Gael, is hard if you don't pay close attention there. And it's just impossible to anticipate all the possible settings and architectures users of your potential container might have. So it's just testing these things on like all these scales is, I think, not very likely or possible. Specific container problems. I think when it comes to containers and setting them up and using them, there's such a versatile amount of options. It's just so broad, and I think it might be too many to like really, because it's not really focused down, and people do different, very like comparable things with very different architectures. And there's a steep learning curve, as with like other useful tools, let's say Python. But you have to get like, it's a good learning curve. You can learn a lot in a short amount of time, but people have to do it, and you have to provide a good amount of training and resources for the people. And possible solutions I see, I think there's no like very good solution like to any of these problems we can do right now. But I think what helps is having community guidelines and combining experience from advanced and beginner researchers, different points of views, developers, different scales, actually what we're trying to do right now, because this is still missing, unfortunately. And we should have standardized tutorials for various aspects of container utilization, from creating containers, running them, to sharing them. And I think we should just try to establish more and more like standardization within that, basically. And with that, I'm done.
Great, thank you, Pierre. I next had on the list Guillaume, part of the team that has done a good bit of containerization and bids apping around SBM. I believe he has family obligations and so can't speak with us today, but he's put his information in this spreadsheet, and we can talk to him separately. So his voice is being heard, but won't be heard in person today. Okay, moving on to more developer on the container side of things, I'll turn the floor over to Satra.
Hi, folks. So I'm going to put 3 hats on today. Today it's a multi-hat day. Many of you know of some of the work we do in building NiPipe, a platform that works across different software. The other hats we put on together with Jarek, we also run a infrastructure for a data archive that pulls in data from cellular neurophysiologists. And then the third hat that I'm going to refer to today is I direct the compute cluster for neuroscience at MIT, which serves about 400 users and spends about 1.5 FTE of support plus system administration effort. So given those hats, let me start with perhaps what I think of as bad about containers. They're bad because they're almost as bad black boxes as many other bad software you use. So just because 2 things are bad doesn't make users pretty good, but you have to keep in mind that you also use a lot of bad software. And if I'm channeling Jarek, as has been started by Gael early on, NeuroDebian or Debian packaging was an effort to create good software packaging efforts to create consistency so that things worked with each other. However, the real world is unfortunately quite more diverse than a very well-defined world of Debian packaging. So if all of us switch tomorrow to use Debian, we would be in a much better place. But I'm sure many of you have run to glibc issues in various things that you've run with, especially in compute clusters. And this is where containers really become helpful. They provide the abstraction or the isolation that's really useful when everybody wants to do something different in a consistent setting. I'm not talking about doing everything on your own computer differently, which is also good as a developer, because you might want to test different versions of MySQL or other databases. You might want to look at different impacts of different software libraries. And for these things, having the ability to quickly isolate complex environments can be quite helpful. However, all of this comes with a steep learning curve. A container is no different than any other piece of software that you've had to learn. Whether it's Python, whether it's Python packaging, whether it's using FSL or SBM or ANTs, you have to learn these things. But it does provide a level of abstraction that can be helpful. And yes, that abstraction hides away. And as I put it in the scorecard, it does not discourage bad software development. Note the double negatives in it. You can still do well with this, but it does not discourage it, which means it gives people the possibility to hide away their bad practices in yet another kind of black box. However, it has been super helpful for various things like running infrastructure. We can spin up things that can be deployed very rapidly that we would not be able to do without containers. It would take a significant cost and maintenance time to do some of the things. As I mentioned, we support 400 users. And one of the best things that happened to that cluster was when Singularity came along. It instantly changed the model of operation of the cluster. Yes, it diversified things that each user now has to be responsible for the software they bring to the cluster, which means they have to learn those things. But it also simplified lives for most users. They were able to do that. and be able to run things without having to run to a system administrator to install their favorite software, which required changing glibc underneath and required an operating system upgrade that shut down the cluster. So those are things that are very useful from a container perspective. Now, there are certain things that obviously people have to learn about. You have to know that a container in some ways is like a computer. So everything you needed to learn about a computer, you need to learn about a container. And you have to spend the time. It's one of those things where it's a hammer and we want to use it for everything. You should not want to use it for everything. You should want to use it for the use cases where they're particularly helpful. Things where you have a requirement for isolation, things where you have a requirement for portability, things where you have some security considerations that you have to deal with. And those are use cases that are very helpful in looking at containerization. Finally, there's a lot of solutions out there, but one of the biggest things I think people need to find out is how well one can find containers that are useful to you. So just like software, there's a world of software out there, and it's difficult to find things that are relevant to you. So yes, you need to learn to build things, but you should also be able to find things, and we don't have that today. So those are things that I think we have to keep working on. Thanks.
Great, thanks, Satra. Moving on the list, we have Val, and Val sent a slide that I'll try to put on and invite her to the floor.
Okay. So hi, I'm Valerie, and I'm a PhD student at Concordia University under the supervision of Tristan Gattard. So my focus mostly works on building tools to improve performance of neuroimaging applications. However, in my lab, there's quite a big focus on reproducibility and also security of containers. So I'll kind of be talking in general about my lab's research, but also my personal experience with containers. So what I see as good personally is that I'm able to test my code in different environments, make sure that's portable so that other people can use them in their respective environments. And that is where I find containers to be great. And also for, like Satra said, for isolating environments. Other stuff is that it also simplifies installation, as in you don't have to think, you just have to do a Docker build and Docker run and it'll install it for you. If you need root privileges on your system, you wouldn't. With a container or like with a Singularity container, you can install that software without needing to have elevated permissions. But the issues I see is that it's kind of used as a band-aid solution for underlying problems such as reproducibility. So I think that as software developers, we should think about building tools that are applications that are reproducible and do not rely on a container to ensure that they produce the same results. Also, they can be quite large in size, and let's just say you're running on HPC. Many people in your lab might be using the same image to run an application, so you can also be using a lot of the storage space just for the containers. So what I think is good but problematic. So right now we're using it to ensure reproducibility, given that our software or the software may not be reproducible given different versions of the software and different operating systems. But the problem is that by fixing the container type, what you are actually doing is making, you're increasing the amount of vulnerabilities that your system may have. Like this is a figure. So a student in my lab, or Bhupinder Kaur, is studying security of containers. And in this figure, so these are all neuroimaging applications with different Linux distributions. And what you can see is that depending on the package size, the number of vulnerabilities may increase. And these are all neuroimaging applications. And so what we have found is that by updating the packages, you actually end up those vulnerabilities are addressed. So they actually disappear, but by keeping the environment fixed, you are leaving those vulnerabilities there. And so what we need to do is we should address the reproducibility issue in our software rather than using containers to address it. And we should always update our containers to make sure that we have the latest version of the software. That's it.
Great, thanks. Let me see if I can get back control. Okay, perfect. And right on time. And the next is Steffen, I believe, and he has a slide as well. And let's go.
Awesome, thank you very much. Hello, my name is Steffen Bollmann, and I'm the National or Ultra High Field National Imaging Facility Fellow at the Centre for Advanced Imaging in Brisbane, Australia. And I'm involved in multiple projects that aim to enable users from all backgrounds to efficiently process the MRI data that acquired our facility. And for this, we're using containers. And the most important and positive aspect for me about containers is that they allow us to run analyses on different platforms, on different computing platforms. And for this, I see the big advantage that users can run the job at the right tool, so at the right hardware at the right time. So one example is a user would start writing analysis scripts on their personal notebook, testing things out quickly on the airplane, making screenshots for a paper. And then if they have bigger data sets, they move to a bigger workstation in the lab. If they analyze a big study, they just move to the whole cluster or even the cloud if it's possible and feasible. Yes, but so that's a really cool thing. The problem is, as we already saw, there are a lot of problems with containers. So first thing is, of course, they're difficult to build and maintain, and we usually don't advise users to build their own containers. So I think if people start writing their own Docker files and they've never built a Docker container, I think this is dangerous because yes, it can involve a lot of, it can produce a lot of security problems. It will probably end up with way too big container, and maybe they're solving a problem that would be much more efficient to do otherwise. So I think good projects to look at this is definitely NeuroDocker. And what we're doing at our institution is we're basically building the containers for our users. If there's a better way of doing it, we will not build a container. Yeah, and also, of course, they're difficult to use. So we are not expecting from our users that they type singularity exec the container and then the program they run, because most of our users would be just confused by this. So what we, for example, build is we build a layer around it that we call transparent singularity that basically just wraps the containers, and they run free surfer, recon all, and it just runs inside the container. But they actually don't have to worry about what container they're using. But if they want to, they can find out with the module system. They know exactly which version of the container they run. And for us, this allows us to run a lot of different software versions, because often users want FreeSurfer 5.30, and then another user wants FreeSurfer 7.1. And this we can just easily enable with containers. And because we give it all in containers to them, they can move this around to the computing platforms. Yeah, and then finally, difficult to use. So in the last week's OHBM hackathon, there was a hackathon project where they said, okay, can we bring all of this technology? So currently, all of the things we're doing are mainly on the HPC side and our workstations that we provision in the center and the notebooks that we can provision. But the question is, can we take this technology out to the users who are not in our facility? And we put together a little project, we call it DNM. So we're basically using containers in a container. So I think Gael will love that. So we're using a big Docker container that runs a virtual desktop. And then inside that, we're running singularity containers with all these different applications, because we have exactly that problem. So even in one Docker container, we can't solve all the dependency problems because we simply can't run FSL View on a modern Ubuntu anymore. So some people just want FSL View. So containers in containers is the only way of doing that. And yes, we are aware that this is not the way to go, but it solves a lot of problems. And ideally, yes, I wish I could just pip install everything or conda install everything or have app, everything would be an app. That would be great. But the problem is it just isn't. There is no free surfer in an app. And even in EuroDebian, it's great, but try to get the latest version of FSL, for example. It's not there. And I think this is what drives a lot of users mad and drives them into the container world. So I'm saying, basically, yes, containers are great. I think we use them a lot where we have to use them because the underlying tools are not developed, they're not there. And I think as soon as the tools catch up and we can pip install FreeSurfer, we would definitely start using that immediately. But currently we can't. So yeah, that's my little 4 minutes, I think.
Yes, perfectly 4 minutes. Okay, let me get back under control here. Okay, let me see who's next on the list. Yeah, Hang-Piang, the floor is yours.
Hello, my name is Chuan-Peng. I'm a postdoc in Leibniz Institute for Resilience Research, Mainz, in Germany. So I think my background is a bit different from what the others because I'm really from like a small team with psychologists and cognitive neuroscientists, and we do not have like specialists who can develop Docker for us. But we really think Docker is the idea of container is really appealing to us because if the packages or the container is well developed, for example, like FMRPrep or MRQC, then it's really easy to use. And I also, I can put those together and use to pre-process our FMR data is quite easy. But then when we try to other things, it's a bit difficult, but that's the bad part. Continue about the good part, then it can also reduce a lot of time for configuring a computational environment. For example, with some open source packages, it's usually because they keep updating, and maybe half a year later, if you have a new machine and if you want to install exactly the same package, then you may spend many hours because the initial try would be wrong. So I think if you containerize, then it will save you some time. And then it will, if you finish one project, it's even a small project. If you containerize all the packages, then maybe half a year later, 1 year later, or many years later, you still can reproduce your analysis. I think recently in psychology, they found that for papers published in Cognition, even the data is available, but it cannot be, the analysis cannot be reproduced. So I think if all the data analysis are containerized, then I think the computational reproducibility may be ensured. So about the bad part, for us as a researcher without really much program skills, I think the bad part is how to really extend existing container or build our own. As Steffen just said, it's actually a dangerous thing, but we have to try if we want to use them, because we cannot limit ourselves to the existing well-maintained containers. And for example, recently I tried to build my a Docker container using an existing container. I just want to add a very simple functionality, like the IPy parallel. But then I found it doesn't work. So I think that part is a bit difficult for us as a researcher. So I think then the good but difficult part is for we as researchers without really strong background in software engineering, then how to extend or how to build our own container for a specific project. It might be not very huge one, but do not need container in container, but still for us, it's a bit difficult. So I think the solution might be maybe more accessible tutorial, or make the build a container easier to ordinary researchers, or have a centralized place that we can just upload our script, then the container will build for us. Yeah, I think that's what I want to share. Thank you.
Great, thank you very much. And we'll move along to Joe.
Okay.
The floor is yours.
Thank you. So I'm Joe Etzel, a staff scientist at Washington University in St. Louis. And the last few years, I've been spending a lot of time on QC and QA and different analyses of the DMCC project. So for a little plug, I put the link on the spreadsheet. But the DMCC project is one I consider kind of medium-sized, because we've been data collecting for 5 years-ish. Hopefully we have a few more years of data collection once we can eventually start again, but with a few hundred people. So it's big, and it's a multi-session, multi-wave design. Eventually it'll all be public, so you can check it out and chat with us if you want some advanced access or whatever it might be possible. But anyway, I don't see us as software developers. We're not, what we need to be able to do is to be able to reproduce our own analyses and to be able to keep our processing and pipeline stable over the course of the project. Because if the people that were collected 5 years ago have different pre-processing that the people that were collecting in February, that would be bad. So, and we really want to be able to share, you know, when we have a publication, to be able to share the analyses that went into it, the whole thing, so that we and others can tell exactly what we did. So that's where we're coming from. And one of the sparks that actually led to this session was that I made a comment during Aga's Open Science Room keynote talk on Wednesday on open workflows, and on Tuesday, sorry. And it was a really good talk, but he was really strongly advocating container usage. And I just started to get this sinking feeling during the talk. And because we've had really mixed experience with containers, and well, it kind of shows in the spreadsheet that I'm actually very hesitant to recommend their use for other kind of psychology type groups if there's not, if you don't have very strong programmer and system administration support. And so in our experience, sometimes the containers can actually make the pipelines and analyses rather less reproducible instead of more, because it can be so difficult to move them to new computers and to take them apart again. So my nightmare scenario wasn't really a nightmare because it actually happened, in that we had one programmer leave and we thought everything was good to go with all the containers. Everything seemed to be working perfectly until it wasn't. And then the new programmer couldn't fix it right away. So we were stuck in this situation of having a program that was just a brick. You know, nobody could get in to fix it easily. And everything's happy now. The programmers collaborated, that everything's working fine. They figured out the bugs. It was related to versioning and things. But that is a really horrible situation. And it's really common to get into that kind of situation in a lab where only a few people know how to run the container, or if it only runs in one place, that's a major vulnerability that you don't want to have that experience. So I don't know how much time I have left, but just to throw out a topic, one thing we're really
50 seconds.
Whoop. Oh, am I out?
50 seconds.
50 seconds. Okay. Well, one topic of conversation, one thing that we've been debating is what the proper use case for containers is. That it definitely seems that if you have a container like fMRI prep, where it's maintained by other people and people who seem to know what they're doing and keep it going and, you know, really have it working, that is a good thing. But for how to release, say, you know, if you have an fMRI study of a big scale, you can't just fit that into one R Markdown document or one notebook type thing. It's just too many stages, because the exact version of AFNI, the exact way you had everything set up matters. And we've thought that one solution to this issue for releasing results might be a container, but we're not so convinced that that actually is a good solution or a feasible one with non-expert programmers. So that's my little bit. Thanks.
Great, and thanks for joining us. And again, I will admit, as we all know, there's your comment and Pierre's comment and something like that that really were quite inspirational to a number of us to try to get this session together. So thank you for putting those issues out there, because it helps us all. Okay, the next Pierre. Speaking of Pierre, and again, I apologize for using your image in vain in that first slide, but hopefully we can still be friends, and the floor is now yours.
So it's my turn.
Yes,
I couldn't hear you well. Okay.
Oh.
All right. So I appeared in those discussions as mostly criticizing containers. So I'm a researcher in Montreal. I'm speaking today mostly with my educator hat, because I'm organizing a number of workshops, Brennack School being one, but training in machine learning. And I'm also the director of the functional unit for neuroimaging, the Fun Center. And we support servers for our users. And so in a way, it's also educational, because we point them to how to use their software. And I have to say that I'm actually very happy about containers in that context. Like, we deploy our software on servers through containers. We also use supercomputers, and it's working really well. It simplified our life, and for users, it's mostly transparent, because we create little scripts that just call the containers for them, so they don't really know how we deploy the software. So I would say, even though I'm here mostly as a critic, I also see a huge value in container. Now, in terms of what I think is bad about containers, in a workshop, there's always some people who will install the container easily. I mean, if you're on Linux, generally it's beautiful. On Mac OS, it's okay. On Windows, with some version, it's great. And then there's like those 15, 20%, and that's awful. If they have an old Windows or whatever, there's so many little combinations. Sometimes you have to tweak the BIOS. So really, if you run a workshop and you decide to go with containers, chances are for a lot of your, well, a substantial portion of your attendees, this is going to be more of a headache than anything else. Also, I was hoping at some point that containers could be kind of a universal ways to package application. And in practice, when you have a GUI, it just won't work. It can work on Linux, although it's not well supported. But if you go on other OSs, it mostly doesn't work. So that's kind of a sort of a disappointment. And some things that can happen even if you manage to install Docker properly for users is that you may have issues with the permission. And people are majorly confused about their file system. So, the way the file system is exposed to users, and the fact that they're actually not themselves from the container is something that creates lots of confusion and can create complete chaos. Something also that happens is that, at least on some distribution, Docker exists in a virtual file system in memory, and your temporary file system is there, and it's very easy to fill it in and explode it if you run a heavy imaging pipeline. So that people whose computer was essentially melting down because of following the workshop. And as a workshop organizer, it's not a great feeling. So yeah, I can keep going. I've noted a couple of others bad thing, but yeah, maybe one last one. It was said several times that containers are meant to ship software. That's how they're used massively in the industry. Originally, containers are a variation on Linux processes that were mostly designed for security, being able to create namespaces for various things. And I think the way containers are designed from the ground up is mostly to ship software instead of other purposes like maximizing security or maximizing reproducibility. So it's not bad per se, but I feel like we're using a variant of containers that actually doesn't fit exactly our use case as a community. So in terms of what is good, everybody said good things, so I'm going to skip. I don't know how much time I have, if I have enough even time.
20 seconds.
20 seconds. In terms of solution, I think something that would be great would be to have Jupyter as what they call the Jupyter stack. And they are pre-made containers that come with a spectrum of useful packages. If as a community we had pre-made containers with a good spectrum and top quality in terms of versioning and security, I think that would be really useful. NeuroDocker is doing partly that, but I don't think they offer a catalog of ready-made solutions. I may be wrong on that, but that was just like maybe like future development.
Great, thank you. Now, again, I threw myself on the end here, but again, I've already been doing enough talking. I did want to make sure to remind us that, as you do get into cloud computing, some of the pre-configured solutions, that Nitric helps provide in terms of lightweight container players that operate out and deploy into the AWS is certainly amongst the solutions for playing things out in containers. But the caveat on containers is all the things that have been being talked about here today. So I wanted it not just to be the 8 of us here. I wanted to open up things to the audience as well to help chime in to specifically elements of this document. And again, we're not going to solve these things today, but this document gives us things to then work on together in terms of solutions and pairing solutions and problems and figuring out what the right things to solve really are. So I can look at some of these chat bits here to see if there's questions or people contributing things. And of course, this document will be open and people can continually add to it as well. There was a handful of questions trying to see if Valerie could say a little bit more about vulnerabilities and example of critical vulnerabilities and things like that. Is Val still there?
Yeah, I'm still here. Yeah, so these could be like, like man-in-the-middle attacks and stuff that are like found in. So I'm trying to recollect on what Bhupinder did, but so it might not necessarily, or it's basically some of the existing code that is on there, or like existing binaries can have vulnerabilities, and how like normally, like every so often you have operating system updates to address those vulnerabilities. Well, the same goes for containers. So there are packages that are on your system. I can't remember what were the other vulnerabilities, so I can't necessarily elaborate on them, but they're just those things which even on your end, on your computer without a container that you may experience, they can also exist within containers, within the binaries that are available in containers. And by leaving them as they are, by not updating them, then you won't get those operating system updates. And so those vulnerabilities will continue existing as you keep reusing the same container that's not updated over and over again. And then I know that she looked into minifying the containers, that is with the repro zip and then removing all the packages that were unused. And she got mixed results with that. So sometimes the packages that were removed were not the ones that contained the vulnerabilities, and other times they could have removed some vulnerabilities. But she found that the most effective solution was just to keep updating the software. So keep your containers updated and the packages within them updated.
Okay, great. And again, we can continue this discussion offline. There is the containers section on Mattermost as well. So thank you. There's a question from Katie from Mattermost. Are the results that cannot be reproduced without the container in which they were originally run, with a reasonable degree of precision, of course, still reliable? She doesn't think so. So I don't know if any of our esteemed panel would like to, I see Gael raising his hand there.
I'd love to comment about this. I really think the focus on archival reproducibility is a complete wrong one. I mean, sure, the only reason archival reproducibility is useful for is to show how horrible something was that has been published is, but doesn't make science better. It just exposes bad science. If something is, there are famous software in this field that gives significantly different results depending on the architecture they run on. I don't trust the result of this software on any architecture, because the fact that changes of architecture change the result means to me that they're numerically unstable and statistically untrustworthy. Does that answer?
Yeah.
Maybe it is possible to have a response to this. I think those are two problems. There's a problem of numerical stability, which is understudied in our field, and there's lots of widely used packages which are unstable, and it is a huge problem. And then there's the issue of just being able to reproduce something you've done. And I think we need to be able to do both. And actually being able to reproduce easily a particular instance of analysis lets you systematically look at what impact what. So actually containers help understanding instability and fixing them. So I think it's a mistake to oppose being able to reproduce to the last decimal an analysis and using stable software there. But both are useful.
So if I can comment, when I was working in the software industry, the policy of the company was that there was no standard installation. Our company was a mess. The reason was that we wanted to use our software in as diverse situation as possible to make it as robust as possible. This is how I do science.
So can I just chime in on that bit? I think that's exactly why containers could be useful, is that you can get a lot of diversity very easily within a given environment. So I think we're kind of looking at maybe two orthogonal issues, right? One is, what are the deficits of containers? But you can actually turn some of those deficits into a positive by saying, if I test across these variations of libraries, that would be really hard to do on my computer very easily without containers. And I think that's really a powerful way of, whether it's numerical stability or understanding how bad a software is as it works across these different environments.
Okay, one last counterpoint on that, and then we'll move to another topic because we only have a few minutes left.
Just like, I think it's important to make a distinction between research software and industry-grade software. It's very hard to get something that's really going to deploy and be robust across many environments. And what containers allow currently is to easily share an entire production environment for a small research project. And that's awesome. And I think a real progress for the field.
Great. Okay. And again, all of these are great topics for follow-up conversation and sections of the forthcoming white paper. Question from Dorota: how do you address the issue that once you have a stable container, some people might be less likely to move to newer versions of stuff? Python 2.5 still works for them. Could be Satra or others to answer that. I see it as a softball.
Well, I think it's the same thing that Gael and I have just mentioned, which is understanding where things vary is a good thing for science. And yes, I know of labs even prior to containers who would not change anything in their software stack lest things be different. And I think over the last 20 years, we've realized that that's not a good thing. So hopefully that's more of a cultural change than a technology issue. And hopefully all the multiverse analysis and other things that are coming out that are showing that there's a lot of variation across scientific output because of differences in software and operating systems and libraries and numeric precision all the way down to live math could potentially be something that the community adopts as saying, we need to move from single isolated environments.
I just want to comment on this, so I fully agree with it. But maybe it's kind of fun because the message that is coming from this panel is containers are great, but not a tool for the reasons that they're used in the community.
I see the opening paragraph from the white paper, but okay, great. Moving along for another question here, might be getting towards our last one from Guillemar. Thanks a lot for the links. Containers with MATLAB. I wonder if MATLAB is self-contained and in general, it doesn't need external libraries. Is it worth the use in containers or as containers? So Pierre is shaking his head, but is muted.
Maybe I can answer this from what I see, what our users do. They run MATLAB scripts, and then from there they have an exclamation mark system call, and then they run flirt and FSL commands from in MATLAB. So that's why they often need MATLAB in our environments. But for example, we don't containerize MATLAB. We just have it normal on the normal platform because it just is a pain to put it in a container. But yes, in itself, MATLAB is self-contained, but then people call external libraries from in MATLAB because it is their workflow.
So if I can comment from somebody who's been working in the Python stack for 15 to 20 years, I honestly respect and admire MATLAB for the sturdiness of their installation and how uniform it is. And this should be our goal.
To be as uniform and sturdy as MATLAB, but just not as expensive. Yeah, okay. or not as closed, or whatever the right thing to pick on is. Okay, fabulous. Yes.
Oh, somebody asked if my experience is, and I assume they mean my nightmare about the programmers leaving, is specific to containers. And I would actually say yes, that the magnitude of the problem is specific to containers. Because even if there's a bug in a pipeline that's more, you have to run this, then you have to run that, then you have to run that, you know, if it's actually a bit documented, if you have the collection of scripts, it's possible to kind of pull it apart a bit and see where the bug is if you're only moderately aware. But if you have a container that nobody can compile, or that it's compiled, I should say, and it's not clear what software is in it or where the bug is at all. If all you know is that the job script that used to work doesn't, then the level of debugging that's required and the level of expertise to do the debugging is a lot more. And so I would say that it's more so with containers.
And I guess my nuance on top of that is, again, this lack of standards about how to create containers and how to document exactly what's in a container and how to make sure it's as translucent a container as possible. And there are potentially ways to do that, but again, often random people making random containers don't do that. So,
and the level of expertise needed to understand that is extremely high for a like incoming graduate student in psychology type of typical computational skill.
The jellyfish blob, okay. Yeah, I guess these comments don't necessarily go out to the rest of the world, but containers are the new binary blob from Gael. Containers are static linking for millennials. I don't know if you meant me to read these things, but then Satra says, I hope a bit more like the translucent and maybe more like the jellyfish blob, okay. There's some meaning in there that I don't completely understand, but hopefully everyone enjoys that. So again, we've come to the end of our time together. Again, the point today was to build a lovely document with lots of good, bad problems, solutions as starting points. This is an ongoing discussion. Again, I've alluded to, hopefully we can come up with, consolidate some of this, pair some of the answers, some of the good, define the places where the good and bad are, define the places where our solutions meet our problems, and identify the problems that have not yet been solved that should be solved, and really be able to work on that as a community. So I thank the panel a lot for joining us and putting up with me harassing them, and thank the audience that we can't see, but we hope the audience enjoyed this, and I guess it'll be recorded and available, and we will come on from here. MATLAB's lack of open sourceness is largely the reason for its stability. Okay, so we'll keep that in mind and we'll proceed. Thank you all.
We'll need to go to Gather Town to discuss the rest of that comment.
Yes, okay.